Hey guys, I'm going to go over a couple of trinomials. These both actually have an a that is 1, or a leading coefficient is 1. It might not look like it, but we're going to talk into this and looking at when we do not have to use an area model or an alternate method. Once we find what two numbers satisfy our a times c and our b, with these, it's a little bit more straightforward. So both of these are trinomials. I'm going to have to figure out what multiplies to give me a times c, adds to give me b. In this first example, I'm going to go ahead and list out my a, b, and c and check and see, because your first step of factoring, no matter which way you have to do it, is to check for a GCF. The smallest number I have here is 1, and 1's not going to change anything if I take it out, and they all don't have n, so this one does not have a greatest common factor. So I'm going to figure out my next step, which multiplies to give me a times c and adds to give me b. So my a times c, 1 times 6 gives me 6, and my b is -5. So my job is to start thinking about the two numbers that multiply to give me 6 and add to give me -5. Now I could think 1 and 6, but one of those would have to be negative, so I'm not going to do that. It's going to be 2 and 3. But I have a -5 when I add and a +6 when I multiply. That kind of reminds me that, oops, I got to make sure that both of these are negative, because a negative times a negative gives me a positive plus a negative gives me a negative answer. So these are my two numbers, which is great. Since my a is 1, I don't have to do the area model or any alternate method that you're shown. I know that these two numbers that help me satisfy this quadratic become my factors. So x minus 2 and x minus 3. If I was to do the area model, I would have gotten these same answers. You can do it to check yourself, but if a is 1, it's not necessary. These two numbers are going to give you your factors, and boom, I'm factored. Now, the second one, the a looks to be 1, but again, remember, we have to check first for a GCF. If I look at 2, 14, and 20, the smallest number is 2, meaning there is a GCF, and that GCF is 2. And that's going to change how I'm going to factor. So I got to divide everything by 2, giving me x squared plus 7x plus 10. So once I took out the greatest common factor, that means I have a new a, b, and c. So my a is 1, my b is 7, and my c is 10. 2 is not my leading coefficient anymore. He's my GCF. So that just means when I get down to my factors, I have 2 at the very front with it. So when I multiply it all back together, it gives me what I started with. So now, yay, a is 1. That means I do not have to do an area model, but I still got to figure out what multiplies to give me a times c and adds to give me the b. A times c would give me 10 and 7. What two numbers multiply to give me 10 and add to give me 7? It's a little bit easier now, is 5 and 2. And since a is 1 now, since I took out the GCF, my factors are going to be x plus 5, because it's a +5, and x plus 2. Again, you can use the area model to check yourself, but, oops, sorry, I put a box around too soon. I got to make sure that I have my 2 up front, but make sure you remember that GCF. He doesn't just go and disappear. There we go. I fixed it. I circled my answer too soon. I got to remember my GCF I took out in the end. And that is it. So if your A ends up being 1, whether you have a GCF or not, you do not have to do the area model. You've just got to find those two numbers, and it helps you find your factors.